Hey guys, one question that I think some of you might have some confusion on is how do we solve an equation by factoring? Um, we have not talked about this a lot, um, but it's something that you should know how to do and you will see on the final exam here on our midterm. Now, something that you should notice here is I have an equation. Well, that's already been solved. It's already been factored for me. I'm assuming that you know how to factor, so we're not really going to talk about that in this video. Um, Check out other videos for that. But let's assume that I've already factored this. I've got x plus 3, x minus 6 equal to 0. Well, I have to know what x is going to be to solve this equation. Rewind for a second. Think back when we solved one-step equations. When I had, for example, x plus 2 is equal to 5. Our goal of this equation was to isolate the variable. Now, in doing so, what we really were looking for at the heart of solving equations was what solution, what value of x would make this equation true. So in the context of this problem, you would be thinking, hey, what number plus 2 would be equal to 5? And I think we all know off the top of our heads, the only number in the universe that would work there is 3. But if you want to do it algebraically, you subtract 2 from both sides. Those cancel, you get x is equal to 3. Now, using that same concept, we're going to take this back here to solve this equation. And think of it, what I'm looking for are values of x that are going to make this equation, this left side, equal to the right side, which is already 0. So really, it's sort of hard to see, but if you think about it, as long as you can just get one of these terms to be equal to 0, these two terms are being multiplied. So if one's 0, I'm going to multiply the other by 0, and I'll get that to be equal to 0. What do I mean? I mean, let's solve this right here, just this first term, x plus 3, if the right side of the equation is 0. So let's say x plus 3 is equal to 0. What would x be? You know, you'd subtract 3, you'd get x is equal to negative 3. Well, I'm going to prove to you that this is a solution to this equation by plugging it back in. If I plug in negative 3, I get negative 3 plus 3 is 0. If I plug in negative 3, I get negative 3 minus 9 is negative 9. And remember, because they're smashed up against each other, these are being multiplied. And 0 times negative 9 is, in fact, 0. So that makes this equation true. Now, interestingly enough, these types of equations actually have more than one solution. So although it may seem like we just did a lot of work and we got x equals negative 3, we still can solve this right side, and what we'll end up getting is x to be equal to 6. If you plug in 6 there, you get out of 0, and that's what we want. Ultimately, guys, if you're stuck on these, pick some values for x, plug it in, see what happens. I think ultimately what you'll find is as long as this right side is 0, this x is always going to be the opposite of this number right here. So for example, notice that this was a 3, you got a negative 3. Notice this was a negative 6, we got a positive 6. That's a pattern to keep in mind there. It might help you out on a test.